welcome to today's presentation, which is the second in a series of presentations on the new e-wiz range of products by PocketNeurobics. The first talk in the series addressed the e-wiz multimodality unit. Today's talk is going to talk about the intermediate E-wiz and H-wiz products, and there will be a third talk that addresses the micro-miniature wireless devices that also make up the suite of products. So, the E-wiz and the H-wiz, why do they exist? Well, for many years PocketNeurobics has been known for their pendant range of devices, and in fact clinicians have asked us for a robust brick that will continue to work through thick and thin, and this is what we have produced. The E-wiz is specific to the EEG range of modalities, so it can address EEG, ECG, EMG, slow cortical potentials, and indeed the OFMA protocols. The H-wiz, H for HEG, can address the Tumen HEG protocol, the NIR HEG, the Karman HEG protocol, which is called the PIR HEG, and it can also accept a pulse oximeter for detecting heart rates and for heart rate variability training. Now, both of these devices are 2-channel, and both of these devices can be either USB operated or wirelessly operated. Now, for USB operation, simply a matter of connecting a USB cable, plugging it into a USB port on the PC. The unit will recognize that it's been connected to a USB port and will start transmitting its data over the USB connection to the application running on the PC. Alternately, the units can operate wirelessly. They both come with batteries. The batteries are not needed to operate in USB mode, but indeed if you're connected to USB and the USB connection breaks or is removed, then it will detect that and automatically start transmitting wirelessly. Now, if you prefer wireless communication, you will also require a PocketNeurobics wireless dongle to go along with it, which is the wireless receiver that plugs into the USB port of the PC. You'll also need the PC application, which most of our clients use BioExplorer, and associated with that is a security dongle, which you'll need to purchase. Now let's talk about each of these individually then. Let's start with the E-wiz. As we said, it is a 4-channel device. There is a ground electrode, active channel 1, reference for channel 1, active for channel 2, reference for channel 2. Now, what is novel and common to all the products in the e-wiz suite is that simply by the press of a button here, we can in fact link the 2 reference electrodes. And that's a common practice for doing assessments, or indeed for 2-channel training. Often it's required that the reference electrodes be linked. As well, the device is a true DC coupled device, but in fact for most training scenarios, in fact you don't need them, in fact prefer them not to be DC coupled. So in fact at power up it is not DC coupled, but again by a long press of this button you can in fact freeze the DC offset removal, and it will act as a true DC coupled device. So that's particularly useful when doing slow cortical potential training and also for measuring the ECG. You can see here we have a mode button. There are a couple of different modes. The modes refer to the sampling rate and the gain applied to each of the channels that's sent over the USB or the wireless link to the PC. So in fact, for the different modalities have different characteristics that they require. For example, for EMG, you require a larger sampling rate to measure the frequencies up above 100 Hertz. And for other applications, you in fact can prefer to use a lower sampling rate to reduce the burden on the processor in the PC. So in fact the modes center around being able to reconfigure the unit for optimum operation for different modalities. It's true too that for gain, the gain required for measuring ECG and EMG is less than that required for EEG, so again, based on the different modes, the gain settings are different. We also note here that there are a row of 8 LEDs, and indeed what this is a real-time display of the signal that is being sent over the first channel, what we refer to as slot 1 to the PC. In the case of EEG, you'll see the real-time flickering here of the EEG. You can then get a sense as to whether if an electrode is coming loose, that indeed the amplitude of the EEG signal tends to increase, and you can get a sense of this here. And indeed, if the DC offset of the electrode becomes excessive, that in fact the signal will go off scale, and that will be a warning to take a closer look at what's happening here. We can also note that it does do electrode offset electrode off detection. If the electrode falls off, the PC application will be notified and an alarm will be set off. In the case of the H-wiz, much of it is common. The modes are common, and the button down here in this case though serves a different function. That with the HEG modalities, as a new feature in the Wiz range of products, the HEG modalities will center or seek out a nominal value of 100. And this makes it easier for interfacing different modalities such as the PIR system and the NIR system to a common design or protocol in the application running on the PC. Now, to search out that nominal value of 100 is simply a matter of pressing the button. The calibrate light will blink on and off to indicate that it's searching for that value, and once it's been established, which may take 10 or 15 seconds, then the light will become steady and you will know that it's ready for training. Similarly, the row of 8 LEDs here, it reflects the HEG signal that is on slot 1. If it is at the nominal value of 100, the lights will be centered. If in fact through training there are some gains, then those gains will be reflected on the LEDs increasing up the scale, and indeed this can be used as a rudimentary standalone trainer. So the different modalities, we have the Jeff Carman PIR system. It has its own socket here. Plugged in thus. The Jeff Carman system. For the Herschel Tuman system, it too has a socket here. And also for pulse oximetry, for finger sensors such as this, they too can be plugged into the NIR socket thus. The device automatically recognizes that a headband has been connected, whether it be NIR or PIR, and reconfigures such that the respective signal from the headband appears on slot 1 going to the PC. So in changing the HEG modalities from PIR to NIR, it's simply a matter of changing headbands. There should be no buttons to press and no reconfiguration of the application on the PC required. It should be a transparent process. Now let's talk about some of the secondary features of the unit. If the unit is, if power is applied to the unit with the mode button pressed, then it comes up in failsafe mode. Failsafe mode is where it can be that because the unit saves parameters from one session to the next session, that in that writing of those parameters, if there is a power surge or what have you, there can be a small chance of some corruption of the firmware. Were that to happen, then you can start it up in failsafe mode and use failsafe mode to download a new version of the firmware. Second feature is that if you start up the unit with the calibrate button or the link button pressed, then it comes up as a signal generator, whereby test signals are sent to the PC application. And this is very useful in determining whether the system is working correctly or not. In the case of the E-wiz, it sends a series of 4 tones, 4 Hz, 8 Hz, 16 Hz, 32 Hz at 1 second intervals to the PC, and if that function is working correctly but the overall EEG signal doesn't seem to be working right, then it would indicate that there is some issue with the electrodes. Similarly with the H-wiz, if you bring it up in signal generator mode, then it sends a test signal to the application running on the PC. In this case, because the nominal value is 100, it sends a test signal of a value of 101 and a value of 99 at 1 second intervals. And again, you can validate the unit itself and the connection to the PC. And if there is some issue, then that would indicate that there is some issue with the headband. Very helpful in fault finding when things go wrong. So let's finish off the discussion with what's required at the initial installation procedure. Now, when you receive the units, you will either already own software, whether it's BioExplorer or BioEra, but if you purchased it at the time of purchasing the E-wiz and the H-wiz, then you would have received a security dongle. This is the security dongle for BioExplorer. It's a matter of initially installing the BioExplorer software from our CD or downloading the latest version from their website at cyberevolution.com. At the installation of the BioExplorer software, a driver for the security dongle will also be installed at the same time. Once that has been installed, the next step is to plug in the USB cable to the E-wiz or the H-wiz, and then plug the other end into the USB socket, at which time Windows will recognize this as a new device and prompt you as to whether you would like Windows to install a driver for it automatically or whether you would like to install it from a CD. Please allow Windows to install the driver automatically. It will go to search its online repositories for a driver for the E-wiz products and come back when it is successfully installed. The key piece of information to remember from that driver installation procedure is the COM port number which Windows has assigned to the Wiz products. That might be COM3, COM4, COM5, what have you. Because that piece of information is the one piece of information that is required to be passed to the application running on the PC. So having successfully installed the driver and knowing the COM port number, you can go back into BioExplorer or BioEra, go into their devices setup window, tell it that you want to use the Wiz driver for these devices, and then within the Wiz configuration panel assign the COM port that was assigned by Windows during the installation procedure. So with that, we would hope that you will enjoy many hours of happy training with the E-wiz and the H-wiz products, and we look forward to seeing you in the next presentation. Thank you very much.